Hello and welcome to another tutorial. We are going to continue our discussion on classes and objects in Java, and we're going to now look at an interesting topic called nested classes. So we want to define a class within another class. Now, why is this possible? First of all, we said that obviously when we have a source file is just like a .java file, all right? And then in the Java file, we can define classes. And we saw that in the source file, we can define multiple classes. So let's go back to these classes, create a basically a new source file. Let's call it nested classes, right? And what we're going to do is, first of all, this is a class definition. So this is a class definition, all right? We said that classes can have two access modifiers, which allow classes in types in the same package, or basically in other packages, to access these types. So for other types like classes or interfaces or any other type in the same package, they can always access the type, because the minimum access level for a class is package level access, which means only the types in the same package. But if we want allow to other types in other packages to access this, we can make it public. So there is no way to hide, basically make a class file, class definition in a source file private. And we say that in to refresh your memory, in a basically in a source file, there can only be one public class, right? So, and then the name of this public class, must match the name of the source file. The name of this one public class must match the name of the source file. Because when this is compiled, if there are multiple class definitions, let's say we can put another one like class, my class 2, for example, or and then we can have a class definition here, right? So this is perfectly allowed. And if you look at what the compiler does, the compiler actually compiles every class definition to a separate class file. So if you look at here, so we have my class 2 and then a nested class, right? And the reason is that obviously each type is compiled to its own class file. JVM is lazy loading, so if you declare this type and nobody uses it, JVM has no reason to load this class file into memory. This might save quite some memory space, because when JVM loads the class file, it has to load the basically bytecode into memory, right? So, and that occupies some space for the JVM, okay? So that's the reason that JVM compiler compiles each class file into a separate into a separate class file, right? Compiler compiles each class definition that you have in your source file into a separate class file, and until somebody tries to use this type, JVM won't load the class file associated with this type into memory, right? It has no reason to. Now, we cannot have multiple class definitions be public in the same source file. So if you look at the compiler error, the public type my class 2 must be defined in its own file. What this means is that you cannot have this public class file be in the source file, because the name of the public class must match the name of the source file. But if this class is public, it has to be in a source file called myclass2.java, right? So that's the reason that we cannot have two public classes in the same source file, because the name of the public class must match the name of the source file. But at the moment, the only solution here is to make this non-public, which means it's package level access. Now, there is no reason to have at least one public class. We can have both of them package private, right? This is totally fine. And if you look at this source file, there is a symbol triangle, which means package private. And if you look at both of the classes that are defined, it means this source file, it gets compiled to classes. Both of them are package private. If I make one of them public, which is the one that has the name of the source file, now Eclipse removes this package private from the source file symbol. So So if all the classes are package private, then Eclipse marks the, also in the tree, marks the source file as package private, which means when this gets compiled, all the classes are package private. All right. So this is the second concept, right? Now, what is the nested class? First of all, when we have class definitions like this is perfectly allowed. And let's make this public. All right. And the thing here is that these two class definitions have no relation to each other. These are completely separate entities. Obviously, one of them can hold a reference to the other one. I can, this nested class, let's call it nested class. So let's refactor, rename. I'm going to say nested class instead of classes. All right. So this class can hold a state, which part of it is pointing to a state of another type. So we can say my class 2 x1, right? So this is perfectly allowed. Now there is a dependency or a relation between this class and this class. Now the thing here is that now you have to, but the classes themselves are independent of each other. For example, if I have a constructor in this class, I can never directly access the fields of this class. But sometimes that's desirable. For example, let's say you have a car, right? Or let's give an example here. Sometimes your class, let's say it's a car, right? There are some, you want to break it down into a smaller pieces, right? So a car has a battery, for example. So let's add a plus battery. A car may have like wheels, right? And these wheels have attributes like how old they are, what's the size, battery is, what is the voltage of the battery, etc. So we are kind of breaking down this complicated object into a smaller objects, right? And this is one of the pillars of object-oriented programming. And then a car is composed of these, right? So you see where I'm going with this. I'm going with the concept of composition. Because composition was about has a relationship, right? Now the thing here is that if sometimes a battery cannot be a generic battery, it has to be a specific. It has to be directly tied to the car, for example, to the car class. Maybe the car class is a particular car. It could be a Tesla, for example. It has a very specific battery, which is not a generic battery. In these cases, instead of defining the battery as a external class, so we can have, I think in the OOP, we already had a battery class. Yeah. So instead of having a separate source file with a public battery class, we can define it in the scope of this class itself. Note that when we define it as a global class in the source file, it means we are declaring in the general scope of the source file. And then it will be compiled as a separate entity, right? But here that's not the case. So we want a battery to be directly tied to the car object, which means if somebody creates an object of type car, we want that battery to be specific to that particular object, right? So let's say we say public car. We have a constructor, and then here we're going to say that let's say a string model, for example, string model, and then different batteries are going to have different types or different voltages based on the model that we choose, right? So so actually it has to be nested class. Let's call it nested. Assume that this nested class is actually our car. All right. So let's have a maybe private field called a string model, and then we assign a reference. So model is equal to model, and you know that we cannot write this because this local variable shadows the global or the field. So we have to use the this pointer, and now this works fine. Right now we get a compiler warning is that this private model is never used, but we're going to use it shortly, right? Now, if I have a battery class, let's say we put the battery outside. So class battery. And then this is going to have a, let's say, a private int voltage. The battery has a voltage, and then a public battery. And then what it's going to get is the model of the car, right? And then based on the model, we're going to decide how much this voltage should be, right? So we can do a switch on this model. We can, in the basic, in our lectures on basics of Java, we know that we can switch, we are allowed to switch on strings because they're constant or final variables. And we want to say if it's, for example, Tesla, it's going to give us basically we can just say voltage is, let's say, I don't know, 15 volts. And then if the case is for example Toyota, for example, then we're going to say that voltage is 12, right? So maybe there are some models that are basically specific. And let's also close the this, and then let's do a other format here. So we can remove these curly braces for the scope. So what we're doing here, we're doing a switch based on the model, and then for that we're going to set a voltage to whatever we want. And let's say we have a public int get voltage. This is a getter, that's the data encapsulation. You're going to hide your fields directly, return voltage. All right, and this works fine. And here the same here, public string get model, we define a getter and return model, and that works fine. All right, so if somebody creates this nested class, which is our car, and then they have to pass the model, and then somebody wants to create a battery, and then obviously we want this car to have a battery, right? So battery, and right now somebody has to set the model and also provide the battery externally. And then we just say this dot battery equals battery. So this is called data or injection, right? So, or dependency injection, which means somebody externally creates this battery and then provides a reference to that battery object. This battery object is initialized, and then we grab that and we assign it to our battery. So this battery and this local variable, which is external, are pointing to the same object. But right now this class, which is our car class, is not responsible for creating this battery, right? However, sometimes we want this to happen because first of all, this battery has to be the model here. So we're kind of repeating the idea that somebody has to pass the model for the car, and then the battery also depends on the model. So there is kind of like a dependency here. The car depends on a battery objects to be created, and the battery objects depends on the model of the car. So and there's a high chance that somebody does not, maybe somebody creates a battery with a different model, and we want to make sure that the models are compatible or the models should match. So obviously here we have to put a check that if this dot model, or in general model, is not equal, know that we can or maybe dot equals or not equal, or equals, let's go equals, and with a not here, equals battery dot now we want to also have a private string car model, and then we want to also assign it this dot car model equals car model. So battery dot car model, and as you can see, it's not available here. This field is not available because private. All right, so this is one of the things that now this battery is an external object. It has no dependency on this class itself. And however, let's say what we want to do is and these fields are all private, so we kind of need to have getters there. Now so far you probably can see that why are we having this car here? So far you've seen the problem, right, with having this battery as a separate entity. There is a close tie or relation between this battery and model, and what we want to do, we want this class to manage this battery itself, right? So obviously one thing that we can do, we can say this dot battery equals battery. We just call that battery, right? And then what we're going to do is so we're going to pass the model here, right? So what's the problem here? The method battery string is undefined for the nested class battery. So right now it assumes that this is okay. We have to call obviously the new operator to get a reference to it. Now it's going to work fine. And this is one idea of having a package level access class, which means now this battery, now this class which is representing our car, is internally managing its own battery, right, based on the model. So you just specify what model, and then some internals provide the battery type. And again, that's data encapsulation, means somebody, the end user, only worries about this car class, and then therefore they don't need to access this type directly. All right. Now, if that's the case, why put this as a now the thing here is that what we want to do here right now, again, there is a dependency, or the idea here is that this variable car model, we have to pass it to the battery again, because right now this class definition battery also is package private, and people don't concern with it. They're only concerned with creating this car class. We still have to manually pass it to the to this battery. So one thing that we can do, and in this case that's the recommended way of doing it, let this class to define the battery, or basically encapsulate the battery itself. So we put this here, and this is now called a nested inner class, nested class or nested inner class. Okay. And now what this allows to do is we're not going to have a string, a car model. It's not necessary anymore. Instead, what we're going to say that we're going to use a advantage of the reason, or the advantage of inner classes, is that they can directly access fields of the outer class. So right now, basically this battery class is our inner class, and this nested class is called the outer class. All right. And now instead of we just keep a voltage here, because every battery has a voltage, but the voltage depends on the model that we pass here. But now, because this object holds a reference to this model, we can just say the model. This works perfectly fine, and this model is the state of the outer class. So if we were to define this battery as a standalone type, sometimes this is the case, sometimes that's not what we want. We have to have the state that holds a model for the car, because now we allow this class to be created independently. However, there is no way to create this battery independently of the outer class, because this battery, which is an inner class, depends on the state of the outer class. All right. Now there is a way to create this battery, and I will show you how to do it. But right now you can assume that right now basically this battery, the creation of this battery, ties to the state of a particular object, and that's what we want, because now we just say new battery, and then this works, and this battery always is aware of the model of the car, right? Because it is allowed to access even the private state of the car directly. That's why it already is aware of what model is it, right? So we can go ahead and do this. So let's have a public battery get battery, for example. Let's hold a reference to it, return this dot battery, or we don't need to even use this. So the reason I want to do this, because I want to do and again, this inner class, nested class or inner class, it's very similar. It's pretty much the same class that you're used to. It's just inside, which means now it has a little bit more capability in the case that now it's allowed to view the state of the outer class directly without you passing them to the constructor. That's the main point, right? The main point is that you don't need to pass a variable to the constructor to be able to access it based on the state of the outer class. You just if somebody creates a model, then this model is already visible to the inner class. That's the main point, right? So let's create a demo class here. Let's call this nested class demo, and let's have a main method. Now we wanted to create a car, right? Car or var car1, Remember, the name was nested class, and we're going to have a type, let's say Tesla. All right, and then let's go and do some to a strings override. So right click source, generate to a string. We want to only select the field voltage, and this just says battery voltage equals something. Same with the source with the outer class model and battery, that's fine. And then model this battery, and when you concatenate an object with a string, it's going to call the toString on it, right? So what we're going to do, I'm going to remove this battery equals something. So let's just say battery. So this string ends here, and then we have a comma plus battery, and then plus this. All right, now if we create this, the battery is automatically created and initialized. It already is aware of the model of the class. And then if we do a sysout on the car1 and right click and look at it, as you can see, we create a nested class. The model is Tesla and battery is voltage 12 volt, right? So let's look at this. If we set it, if it's Tesla, we're going to set it to 15, and then after that we set. So why is this? Let's see, why are we not getting 15 here? If the model, so let's see, new battery, self.model. That's very interesting. Let's try to debug this. Let's do a sysout on the car1.getModel, and it's Tesla, so that works fine. Let's make sure that this line is executed. Voltage is 15. We want to make sure that this line is executed. Voltage 15. But why is this saying that voltage is 12? That's very odd. So voltage 15. Oh, okay, that's because we don't have the break. So be careful about this. Otherwise, so yeah, we were falling into the trap of fall through. So trap of fall through. So always be careful about the switch. Make sure that you have the brakes. Otherwise, voltage is 15 and then voltage is 12, because when the first case matches, the other cases become invisible. Now this works fine, right? Yes. So voltage is 15 Tesla. If we say Toyota, then it's going to give us 12. Yeah, so the battery is correct. We are not specifying the battery. The user of this class may not even know the battery exists, because that's a internals of the class itself. Battery is a dependency, and the reason we created a battery class is because we want to go with the best practice of object-oriented programming, which is break down a large object into a smaller objects, and then you can define them as inner class if there is a very tight relation between the battery and car. Basically, battery is supposed to depend on the state of the car, or the model of the car in this case, right? Model is the state, and the reason is that different car models like Tesla or Toyota, they might not have, or they might not accept a generic battery, right? They might have obviously we already know that Tesla has a very different battery than regular cars like Toyota. That's why we decided to go with the inner class. Inner class, the model is already available, so the state of the outer class, in this case this class, nested class, this is our outer class. That's the terminology. And the state of the outer class is always visible to the inner class. And then sometimes we call this nested class or nested inner class. These are called non-static classes. Inner classes can be static. We will look at it in the future, and you can probably guess what happens. The static inner classes can only access the static state of the outer class. Right now, these two states, these two fields that hold the state of this class are non-static. So they're not visible to static inner classes. They're only visible to non-static inner classes, like this battery, right? So again, the reason we move this battery class let's also add the break statements here. Let's not forget that. Always be careful about the switch and break. So the reason we moved this battery class inside inside our class and made it an inner class was because if we allow this to be standing freely and not depending on anything else, then we have to pass this string car model, because battery depends on what model we're talking about. But then whenever somebody wants to pass this battery the model, then we had to pass this model also here, right? And there was a chance that somebody might create a battery outside this class, because this is still accessible to all the types in the same package. But now we want to make sure that if somebody wants to create a battery, it has to happen in the context of a particular car. What this means here is that we can't say a new battery. This is not allowed. This is not allowed. Okay, so how do we create a battery? So how do we create an object of nested inner classes? Now, obviously, there is a reason that this class is a nested class, and that's because we probably didn't want anyone to be able to directly instantiate this. But Java language allows it as long as this inner class is public. Note that. Let's make it public. Right now it's package level access, and we are in the same package. That it still works fine. But in order to be able to create an object of this battery type, first we have to be able to access it, which means because now it's inside the outer type, which means the outer type should be accessible to us. So if we are in another package, this outer type should be public, and then the inner type should also be public. It could be private, for example. That still works. And this is one of the cases that I said that the private is allowed on this class definition. And because we know that we can't confine a variable or anything within the scope of a class just marking it as private, right? What this means is that now this battery class is never accessible. Now is never accessible outside the scope of the class. Now if we don't provide any modifier, it's still package level access. So if this class is accessible to us and we are in the same package, we can access this. Alright, so the way we're going to create a battery type, obviously it's tied to the state of a particular state. So this battery class is tied to the state of a particular object, which means we cannot say new nested class, or we cannot access it directly via the type nested class dot battery, right? This is not and this is not visible. So so let's assign it to var b1. Now this is not, we cannot use the name of the outer type and then the inner type. This is not allowed. Why? Because this means we're saying that this battery is a part of the class, not and it doesn't depend on any particular object. So this is not correct. If you look at the compiler gives you a very weird warning. This is I guess the weirdest error that you ever see, and we're going to decode what this means. So let's copy this, let's paste it here. Alright, let's break. Alright, let's see what the error is. No enclosing instance of type nested class is accessible, which means right now you're accessing this type directly via this class, which means you're not tying this object b1 to any particular object. But we know that must qualify the allocation. When you call the new operator, it goes to allocates a memory for this battery type. Must qualify the allocation with an enclosing instance object of the type nested class, e.g. x.new a, where x is an instance. So it's giving you an example of what to do, and basically what the compiler is telling us to do is that you have to use a weird syntax. I think this is the weirdest syntax in Java. You have to say car1, this is the object, not the type, dot, and then new, and then battery. Now this is allowed. Why? Because this battery relies on the state of this object. So when you say car1 dot new battery, it means create a new battery, and the JVM knows that this is an inner type. But then this battery depends on the state of this car. So when we create this, the battery reads the state of this particular object, and then it realizes, okay, the model is Toyota, so I'm going to create a battery that is based on the model of this particular car. And we do a sysout. If we do a sysout on B1, obviously you will see that this is correctly generated. So zoom out, run Java application, battery 12 volt, right? If we say this is, for example, Tesla, then battery is 15. So in order to create an instance of the inner class, you have to call the new operator with the dot operator. So you say that the object, you create an object of the outer class first, and its state is now fully initialized, because the inner class depends on the state of the outer class. So you cannot directly access via the class name or the type. You have to access it via the instance. This is one of the cases that you don't use a fully qualified name on the instance reference, right? So this is literally an instance, a reference, or a pointer to a created object. This is a variable. So you call the new operator with the dot operator together on this variable, and then you say the type. Now obviously the constructor of this object might accept other types, other variables, that's fine. But right now we know that this battery only needs to know what the type of the car is. And then the coupling is in this way that battery is an inner class, so you can immediately access or read the model field, the state that this car1 holds. So you say car1, which is a variable, a reference to a created object, dot new battery, and then JVM goes to this car class and reads what the model is, and then initializes this class in the constructor. We're using the model, which is the state of this car, and everything works fine, right? In the next lecture, I will actually show you the bytecode and tell you what exactly happens. How is this possible? And we will see that, first of all, the rule still applies that every class definition, even a nested inner class, is going to be compiled to a separate class file. All right, that's the rule. That's always the case. That's how Java compiler works, right? But then there is something must happen so that this battery is always aware of the state of the outer class, and we will see what happens. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.